Unit 1, Lesson 5 is solving equations and inequalities by graphing. So my lesson essential question is, how can you solve an equation or inequality by graphing? At the end of this lesson, we'll be able to use graphs and tables to approximate solutions to algebraic equations and inequalities. Example 1, use a graph to solve an equation. How can you use a graph to solve an equation? Solve negative 3x plus 20 equals 5 by graphing. An equation is a statement that two expressions are equal. The values that make the equation true are the solutions. To solve an equation by graphing, write two new equations by setting y equal to each of the original equations. So I have negative 3x plus 20 equals 5. So I'm going to set y equal to negative 3x plus 20. So the left side of my equation, and y equals 5, the right side of my equation. I graph the two equations and identify the points of intersection. These points will have x values that produce the same y values for both expressions. Each of the x values is a solution to the original equation. It appears that y equals negative 3x plus 20 and y equals 5 intersect at x equals 5. By substituting this value into the original equation, you can verify the result. So negative 3x plus 20 equals 5 when x equals 5. This is the only point on the graph where the value of the function y equals negative 3x plus 20 and y equals 5 are equal. How can you use a graph to solve an equation? Solve the absolute value of x minus 4 equals 1/2 x plus 1 by graphing. To solve the absolute value of x minus 4 equals 1/2 x plus 1, I write two equations. Y equals the absolute value of x minus 4, the blue equation, and y equals 1/2 x plus 1, the red line, and graph. It appears that y equals the absolute value of x minus 4 and y equals 1/2 x plus 1 intersect at x equals 2 and x equals 10. The solution to the equation, the absolute value of x minus 4 equals 1/2 x plus 1, are x equals 2 and x equals 10. You can verify these values by substituting them back into the original equation, which I always recommend that you do. All right, so let's try it. Use a graph to solve the equation. So the nice thing is they've already got a graph set up for us. So I have two equations, 5x minus 12 and 3. So y equals 5x minus 12 and y equals 3. We can see that they cross right here at 1, 2, 3. X equals 3, y equals 10. Or y equals 3. Sorry. So x equals 3. Okay. This is actually a product called Desmos, which you have access to on your computers. You just type in, put it over here. www.desmos.com. That actually, you can use that to graph any of your equations for any math class, any Algebra 2 class that you have. Okay. Then we're going to use a graph to solve the equation. Negative the absolute value of x minus 2 equals negative 1/2 x minus 2. So again, I just type in my equations. So it's just one side of my equal sign and then the other side of my equal sign. Y equals negative 1/2 x minus 2. Okay. I can see that this one crosses at 2 points. Okay. So we choose at x equals 0, there's it right there, and at x equals 8. So x equals 0 and x equals 8. Be very careful when you're actually figuring out your solution. Notice that this is from 0 to 10, not 0 to 5. I mean, I can go in further to make each one of these an individual line, but just make sure that when you're reading the graph that you know what increment it's going by. Okay. You can always substitute those values back in. They should work. So 0, if I plug in 0 here for x and here for x, they'll equal each other. Okay. All right, example 2, solve a one variable inequality by graphing. How can you use a graph to solve an inequality? Solve x squared minus 4 is greater than 0. To solve the inequality, identify the values of x that make the value of the expression x squared minus 4 greater than 0. So I graph the equation y equals x squared minus 4 by translating the parent function y equals x squared down 4 units. Okay. The graph of the function is positive over the intervals in negative infinity to negative 2, so the blue sections, and 2 to infinity. So x squared minus 4 is greater than 0 when x is greater than negative 2 or x is greater than 2. So the blue section. How can you use a graph to solve an inequality? A motorcycle is 40 miles ahead of a car. The motorcycle travels at an average rate of 40 miles per hour. The car travels at a rate of 60 miles per hour. When will the car be ahead of the motorcycle? So I let x represent the number of hours since the car started traveling. The expression 60x represents the distance the car travels in x hours. The expression 40x represents the distance the motorcycle travels in x hours. To solve, we need to determine when the number of miles the car travels exceeds the number of miles the motorcycle travels. So 60x, which is the miles per hour of the car times the miles it traveled, or the hours it traveled, is greater than, because we want to know when the car will be ahead of the motorcycle, miles per hour, 40 times the hours it traveled, plus 40, because the motorcycle was 40 miles ahead of the car. So I set y equals 60x and y equals 40x plus 40, and then graph both equations. This part of the graph shows that the car has passed the motorcycle. Okay, so this blue line, that's my car. The red line is my motorcycle. So we can see this is where the motorcycle started, okay, and it traveled this constant speed for this many hours. The blue car started at 0 and it traveled 60 miles per hour. So this is the blue. It appears that the point of the intersection is 120. At this point, the car has caught up to the motorcycle. So at this point, 2 hours in, they've both traveled 120 miles. This bottom part of the graph shows that the motorcycle is still ahead of the car. So anything after this point, after this 2,120 point, the car is ahead. Okay, so anything that's greater than 2 hours. The car will be ahead of the motorcycle anytime after 2 hours. You can verify the solution by selecting any number greater than 2 and substituting it into the original inequality. All right, so let's try it. Use a graph to solve the inequality. X squared plus 6x plus 5 is greater than or equal to 0. Notice the greater than or equal to sign. Okay, so I'm going to go ahead and graph this. X squared plus 6x plus 5. Also, if this isn't out, you see the hide expression list. So if you just see this, you have to click on the little arrows. Okay. So here's my graph. Now I want to know when this is greater than 0. Well, here's 0. Here's x equals 0. Okay. Greater than or equal to. So it crosses at -5 and they cross at -1. Okay. So those are my 2 points. So anything this here, anything from -infinity to -5 is greater than or equal to 0, and anything from -1 to infinity is greater than or equal to 0. Okay, this is negative, so we want to ignore. Okay, so when x is less than or equal to -5, when it's smaller than -5, so it's -6, -7, it'll be greater. Or when x is greater than or equal to, notice I'm including the equal sign. In our original example, they didn't include the equal sign because it was a greater than as opposed to a greater than or equal to. So x is less than or equal to -5 or greater than or equal to -1. Use the graph to solve the inequality. X plus 3 is greater than 7 minus 3x. So again, I want to graph both of my equations. So y equals x plus 3 and 7 minus 3x. You can also include the y equals. It'll give you the same thing. Okay. So here's my 2. So this is my first one. They cross at 1, 4. So that means, well, my red one to be larger than the black one. So at any time after x equals 1, it will be greater. So x is greater than 1. All right, example 3. Use a table to solve an equation. Use a graph and table to solve the equation x squared minus 4x plus 1 equals x minus 2. Okay. So again, I sketched the graphs of y equals x squared minus 4x plus 1 and y equals x minus 2. Identify points of the intersection to find the estimate or estimates of the solution value or values, depending on how many times it crosses. So one solution here lies between 0 and 1, and another one lies between 4 and 5. Okay. Neither solution appears to correspond to a grid point, so it's not an exact point. You can use a table to get more accurate estimates for the solution. Select the green rows of the first table to analyze values between 0.6 and 0.7. So notice that it's from 0 to 1. It's probably going to about halfway is here, so it's probably going to be closer around here. Okay. So notice here at 0.6, well, you can get even more specific to 2 decimal places, to 3 decimal places, to 4, you can keep going. Okay. So if x is greater than or equal to 0.6, then x squared minus 4x plus 1 is greater than x minus 2. If x is greater than or equal to 0.7, then x squared minus 4x plus 1 is less than x minus 2. So I'm looking for values where graphs will cross. Use these values to zoom in, finding better and better approximations, or choose the x value with the smallest difference in the function values. So the nice thing with Desmos is you can actually zoom in more and more, and when you click on it, you can usually find a point. All right, so let's try it. The equation x squared minus 4x plus 1 equals x minus 2 has a second solution in the interval between 4 and 5. Use a spreadsheet to approximate this solution to thousands. Okay, so here's the approximation. It looks like it's going to be less than 4.5 because it's not quite halfway there. So it's probably around the 4.2, 4.3 mark. So what I'm going to do is use a spreadsheet in order to solve this. So basically I start plugging in information. When I do that, I will get x is approximately 4.303. Okay, so here if you look at the graph, you can see I've graphed the x squared minus 4x plus 1 and the x minus 2. It does give me 4.303 as my x value. All right, example 4, use graphing technology to solve equations. Use graphing technology to approximate the solutions of the equation negative x squared plus 8x minus 13 equals the absolute value of x minus 4 to the nearest 10. So again, I graph my two sides, and I use the intersect feature on my calculator, or if you're in Desmos, you just click on it to find the intersection. The intersect feature shows that the equation has solution x is approximately 2.7 and approximately 5.3. Remember, you're looking at the values of x. All right, so I'm going to use graphing technology to go ahead and graph these two, x squared plus 2x minus 1, and the absolute value of x plus 2 plus 2. Okay, so here they do it so nicely for us. My 2 points. So I have negative 3.303. They want me to round to the nearest 10th. So x is approximately 3.3 or 1.8, because 1.79 would round to 1.8. So or 1.8. Sure. This one's removed. All right, concept summary. Solving equations and inequalities by graphing. When I solve inequalities or equations, I take one side of the equation and I graph it, and then I take the other side of the equation and I graph it, and identify the points where they meet. And I'm looking at the x values. Okay, so one solution appears to be 0, the second solution appears to be -3. When graphing with technology, I can use the intersect feature or click on it if it's Desmos. I can also use tables. Graphs may not always yield integer results. Tables may be used to find solutions where you can always double check substituting in your x values to see if you come up with the correct value or they're equal to one another. And that is the end of Unit 1, Lesson 5.